Okay, so in this video I want to just look at some theory, some basic things in the acid and base topic, and we are going to start with the definition. Okay, so the definition, there's two types of definition. One was by a guy with the name of Hydrolysis, okay, and he defined an acid as releasing H plus ions, or instead of H plus it could be H3O plus. Okay, H3 ions in water. Okay, so whenever you have a substance that you are dissolving in water, it produces the H plus ions. Okay, so we call that dissociation. Dissociates. Okay, means it breaks up into ions. Okay, that's what Hydrolysis said about an acid, and then Bronsted-Lowry. That's one guy. It's like a funky struck through the O. Bronsted-Lowry, they said they defined an acid as a proton donor. Okay, a proton donor. Now, see, it fits in with Hydrolysis' definition, because if you release H plus ions, H plus means it is the hydrogen molecule without its electron. Okay, in which means it only has its proton. So that is the Hydrolysis and Bronsted-Lowry definition for acids. Okay, the alternative is true for a base. Okay, so the two also have definition for bases. For example, Hydrolysis said a base is it releases or dissociates OH. Okay, OH molecules. Not molecules, ions. Okay, while Bronsted-Lowry said that instead of it being a proton donor, it is a proton receiver. Okay, so it receives protons. Okay, so that's the definition. Now, what happens whenever we take an acid? Okay, if I were to take an acid and I were to dissolve it in water, okay, what we will get is it will ionize. So we'll get our H3O plus ions. Okay, so if I write it like that, I need to put this as water. Okay, I'll need to put this plus H2O. This will produce H3O plus ions plus another negative ion. Okay, anion. Okay, so when I do that, you'll remember that when we're doing reactions, the reaction doesn't maybe happen completely. For example, not all of the acid molecules dissociate. Okay, now in a strong acid, all it dissociates completely. Or almost completely, at least. Completely. Okay, the same goes for strong base. Okay, so for a base, we will have a base plus H2O would produce an H3O plus anion plus OH negative. Okay. I think so. Well, important part is it produces that. Okay, and again it dissociates. Okay, and a strong base dissociates completely. Okay. A weak base or a weak acid, obviously not. Okay. What am I writing here? Base. Okay, does not dissociate completely. Okay, so when I do dissolve it in water, we still get our acid, some of our acid that has not dissociated, or some of our base that has not dissociated. Okay, so let's just look at a few strong and a few weak bases, and these are important. You have to know which are the strong acids and which are the strong bases. So for an acid would usually, if not always, start with the hydrogen molecule, okay, or the hydrogen ion. And one thing that you can almost remember is that if we have it like this, where X is the halogens, okay, halogens, okay, that's column 7 on your periodic table, okay, the second last column. Those usually form strong acids, with the exception of one. Okay. Hydrofluoric acid is a weak acid. Okay. And then there's two more that's going to be important, and that is sulfuric acid and nitric acid. Okay, those are three. Well, there's a few here. That's hydrochloride, hydrobromide, hydroiodine. Okay, they're all weak, strong acids, and then including these two. Weak acids is here's just an example. Okay, so if you are given any other acid, it would be a weak acid. If it's not one of these that we mentioned, keeping this in mind. Okay, then strong bases. Strong bases is a base would end on OH. Okay, and in the front, okay, we will have an alkali metal. Okay, actually any two of the first two columns. If I have any of the first two columns in here, it should be quite a strong base. Okay, weak bases would usually be a base that doesn't have the OH in it. One of the most common weak bases that you will encounter is ammonia. Okay, now for both acids and bases, we can have water as a weak acid or a weak base. Okay, so just to quickly go over, so an acid is a substance that provides H plus ions when it's dissociated in water. A base would associate into OH ions. A strong acid is an acid that dissociates completely. A weak acid is then one that does not. Strong base, the same thing, it dissociates completely. Okay, weak acid does not. Strong acids that we've looked at is anything starting with hydrogen and then one of the halogens, with the exception of hydrogen fluoride and water. Okay, strong base usually ends on OH, okay, and when the first the ion, okay, that is the cation, the positive ion, is one of the first two columns, the alkali metals, okay, then it too would be a strong base. Weak bases, one of the most prominent ones would be ammonia. So that is what we have so far. Now let's quickly look at concentration. So we looked at definition, at strength, and now concentration. Okay, so we've just said that we are putting an acid plus water. Okay, so what we're doing is we're dissolving acid and water, or a base and water. Okay, the standard solution in a standard solution is when I have 1 mole per cubic decimeter. 1 mole per cubic decimeter, and another way of writing this is just 1 capital M. This capital M is mole per decimeter. So this is the standard solution. Basically what that means is if I look at my my solution, so I've got my solution here. Okay, there's my solution in a container. If I take 1 cubic decimeter, that means I take a little space like this, okay, where it's a decimeter, that's 10 centimeters by decimeter by decimeter. Okay, if I take that much space, or I take a little box like this and I fill it with this solution to the brim, I fill it up with that solution, then in here would be 1 mole of the acid or the base. Make sense? Okay. If I have anything less than that, it is called a dilute solution. It is not the standard solution, it is a little bit diluted. Anything more than that is called a concentrated solution. Okay, and we're going to look at now is some salts. Okay, what happens when an acid and a base? So remember, an acid is H plus, and then usually, well, not usually, it's always H plus an anion. Okay, and then my base is a cation, and then usually OH. Okay, not always, but I'm going to look at this. So remember, anion, negative, cation, positive. Now what happens when an acid and a base reacts with one another, they produce salt, and the salt would be my cation and my anion reacting, plus, and then this one donates the proton, and this one will accept the proton. So that will produce a water. So, and this would be a salt. So it will produce salt and water. Okay, so for example, I can have hydrochloric acid plus sodium hydroxide, and that will produce, okay, what's my cation?
It's disodium.
Sodium, so Na, my anion, chlorine, sodium chloride, this is normal, table salt, okay, table salt plus water. Make sense? Okay, now imagine this. You've got a container. You pour in a solution, or you pour in I don't know how you pour it in, I can't remember. Okay. But we okay. So we will have our base, our acid. So we have our hydrochloric acid added to our base, which we said is sodium hydroxide. Okay, when it is added, what is going to happen in here? What are we going to get in here? And water. So this is going to be a salt solution. Okay, it's going to be salty water. Okay, now what happens when you add something to water? Okay, it dissociates. Okay, it dissociates. So what do we have? We have Na plus Cl. Okay, now the water itself, remember water H2O is still part of this process. Okay, so but when I put something in, when I dissolve something, it dissociates. Okay, but water is polar. Okay. So what will happen is it will attract some of the, which one is positive? This one is positive, that one is negative. Okay, it's got a little bit of an extra negative charge. Okay, because of the big atom of oxygen. So it will attract the sodium. Okay. Now what's going to happen is that it is then possible for us to get this again, our base. Okay. And then in other words, this one can also dissociate into H plus and OH. Okay, remember before we said this could be an acid or it could be a base. Now what this is called is the hydrolysis of salt. Okay, so what the hydrolysis of salt is the dissociation of salt to produce a weak acid or base. Now, this was actually a bad example because it won't happen for this reaction. I'll show you now just why. Okay, so in other words, even though we are producing a salt, the salt reacts with the water and it ionizes in the water, and then the water itself, the water ions or the ions in the water molecule can now again react with the ions in the solution, and that can again produce an acid. Okay, now when will this happen? Well, we've got different options. If we have an acid, a weak acid, or a strong acid, and we have a base, a weak base, or a strong base. Okay. So remember now, when a base and an acid react, it produces salt and water. But the salt that's produced in the water dissociates and can react with the ions in the water molecule itself. If I have a strong base and a strong acid like I just had, it won't spelling it wrong. How do you spell it? Yeah, that's right. It won't dissociate. A strong acid and a strong base, the salt that it forms, have a very strong bond. This has a very strong bond. Okay? So it won't dissociate. If however I've got a strong base reacting with a weak acid, it will produce a weak base. Okay, so the salt will dissociate, producing a weak base. Make sense? In the water. If I have a strong acid and a weak base, it will produce a weak acid. So it will dissociate, producing a weak acid. If I have a weak base and a weak acid, okay, then what I'm going to have to do is I'm going to have to look at the Ka value compared to the Kb value. Whichever one is greater, okay, maybe I'll show you what Kb is just now. Okay, so then we actually have to go and measure a value. We know that the K value for a reaction is found by taking the concentration of the products divided by the concentration of the reactants. Okay, so the concentration of the acid we will take the concentration of H plus ions, okay, divided by the concentration of your acid. While Kb would take the concentration of OH ions divided by the concentration of your base. Okay, whichever one of these two is greater, well, that's going to tell you whether it's an acid or a base. Okay, make sense? Good. Okay, let's move on to pH. Okay, so pH is simply defined as a formula negative log of H3O plus or H plus. Okay, so to get the pH of a solution, we need to know what is the concentration of the the concentration of the hydronium ion. You need to know that, or if you don't know the concentration of the hydronium ion, you could, but you do know the concentration of the hydroxide ion. In other words, you know OH. Then you can get the pH by taking 14 plus log of this. So it depends what you're working with. Usually they would give you a strong acid, and they tell you that this strong acid has, and they give you, let's say, X mole per cubic decimeter. Okay. Then you know, okay, strong acid dissociates completely. What that means, if I've got my acid in my water, okay, then I get H3O plus ions plus whatever else we have. But then I know that the concentration, since the acid dissociates completely, all of the concentration of the acid, and obviously you'll do the balance. You balance the equation, and usually you don't need to add any, sorry, that shouldn't be there. You usually don't need to add coefficient, but let's say there was a coefficient, you'll just know, well, that means if this one is this many moles per decimeter, then this one will be the same, or we multiply then just with the coefficient. Okay? That's if they give you a strong acid and you have to calculate the pH. If they give you a strong base, okay, then we just know that it's base plus water, okay, dissociates completely, and that means that all of the base, okay, the reaction is to the far right, all of the base dissociates, which means all of the concentration of base gets converted into the two, sorry, I should stop adding those, into the two ions, whatever the other ion is, okay, which means that if they tell you that the strong base has a concentration of that, then we just see, okay, we know the concentration of the hydroxide, which means we're going to use this formula. Very important. Or you can just use this formula and subtract it from 14. Okay, get an answer and subtract it from 14. Good, that would give you the pH of a value. Okay, let's just quickly look at the pH scale. Okay, 7 would be neutral. That means it's neither an acid nor a base. Anything more than 7, suppose 7.5 up to 7 between, let's say 6.5 to 7.5 would be more or less neutral. When it comes to 8 and higher than that, it becomes a base. Okay, so the pH of a base will be up here. The pH of an acid would be down here. The closer I get to 0 and the closer I get to 14, the stronger my acid becomes. Okay, so suppose anything more than about 10, anything less than about 3 would be strong, considered strong. Okay. And now we get to where you're actually going to do most calculations. So we would do some calculations there, but now we get to where we do most calculations, and that is in a titration. What a titration is finding an unknown concentration of an acid or a base using a known concentration of, and then just the opposite of a base or an acid. Okay, so just as an overview of this, and then we will go and do the calculations. What you will have in a titration experiment is basically two apparatuses. Okay, you will have your beaker with your unknown concentration. Okay, if it's not the unknown concentration, it would be the one that is okay, I'll do it here. So in the burette or pipette, okay, that is going to be an apparatus that we're going to use to add some of the alternative. So this one can be an acid or a base, and this one will be a base or an acid, the alternative. This one will either be the known concentration. I will either know how much is in here, known, or it would be the one that we have in excess. Okay, I do need the one in excess to be known. Okay, so that's why I usually will have it that way. Okay, so what we will do is we don't know what the concentration is in the beaker. We do know what is known is the volume. We know how much we have in here. We just don't know of this volume what is the concentration in here. Then in the burette, what we will have is we will know the volume and the concentration. Okay, so we will know volume and we will know concentration. Both of these values are known. And what we will do is we will slowly add drop for drop of this, either acid to a base. And what will it produce when we add an acid to a base? It will produce a salt and water. Now in the end, we want the salt and the water to be neutral. So while we are doing this, we are measuring the pH. While we are doing this the whole time, we've probably added some sort of indicator that you can mix with your solution at the bottom, and it will have a certain color. And that color will instantaneously change the moment it becomes neutral. All of a sudden it will either be clear or be yellow, depends on what indicator you use. Okay, and the moment we see that it's turned neutral, we measure how much did we use. Okay, so in other words, what we need to measure first of all is that is our first aim, is find moles used. Okay, that was of the known. The second thing that we know now is that in this reaction, for example, the reaction we had up here, okay, we could see that 1 mole of this reacted with 1 mole of that. Doesn't matter what happens on the other side, that's important. 1 to 1. So sometimes it can be different, especially when we work with H2SO4. Okay, and then we can see we might have to balance the equation, and then I might have to have 2 of whatever I have on this side in our H to produce whatever is on that side. Okay, and in that case what we will know is then we will know how many moles was in the unknown using ratios. And our whole aim is to find the concentration, usually, and to find the concentration, since we know, so now we have mole, okay, and now we just use C is equal to mole over volume, because we said we did know the volume in that beaker. Okay, so that's basically it. However, we're going to look at a question now that completely seems to throw all that out. Counts 10 marks. Okay, and it's really not that difficult if you just keep in mind what you are trying to do. Let's go and look at an example.